Welcome to episode 3. I'm PaleoZoen, and today's episode will be slightly different than the first two. The first two, I covered archaeology. And archaeology is the study of the stuff humans have left behind. Um, and as you may or may not know, archaeology is one of the four fields of anthropology. The other three are linguistics, cultural anthropology, and biological or physical anthropology. And this subject will fall into that last one. I also want to preface this by saying this is an editorial piece, meaning after studying this topic, and this is my favorite anthropological topic, is the history of human evolution, the study of the biomechanics of the human body. Um, After studying it for a lifetime from my armchair and then having the opportunity in the last 7 years to go to school and study it officially academically, um, these are the feelings I have about some of the literature. And I feel like when we talk about humans, we automatically place ourselves above nature. So I don't do that. I believe we are also animals. If that offends you, maybe this isn't the channel for you. So let's go ahead and get started. In the animal kingdom, or the terrestrial animal kingdom, I should say, we have two main forms of locomotion. We have bipedalism, which is the act of walking on two legs, and far more common quadrupedalism, which is walking on four legs. Of course, there are many subsets of these, but those are the two main, and humans, of course, are bipedal. In paleoanthropology, the emergence of obligate bipedalism, which is full-time locomotion on two limbs, in humans and human ancestors and human relatives, is often framed as a landmark evolutionary event. And while there's no doubt that the shift to obligate bipedalism had profound effects on our species development, I find the way we treat it as some kind of miraculous adaptation coming from the ether, lacking in the broader evolutionary context. Humans are not the only creatures capable of bipedal locomotion, nor did bipedalism spring into existence out of nowhere. Many mammals, including apes, monkeys, squirrels, bears, kangaroos, and even ground sloths, engage in forms of facultative bipedalism. Birds are bipedal when they're on the ground or in the trees, as were their theropod dinosaur ancestors. Monkeys and apes are often bipedal in arboreal or tree-dwelling contexts and can walk short distances bipedally. We see it all the time. Yet, paleoanthropology too often portrays human bipedalism as a sudden breakthrough rather than part of a continuum in mammalian evolution. The fact that bipedalism is not quite so special as we are taught that it is came to my attention during my undergraduate research for a paper on North American calicotheres for paleobiology class. Um, these are fascinating animals. They're huge herbivores related to horses and other hoofed animals, except they had reverted back to claws. It's a complicated thing. I'll do a video on them in the future. But they were adapted for bipedal browsing. They had very long arms and very short back legs, and sitting on the short back legs to balance while they reached up to grab tree limbs for eating. Um, so studying how they did this got me thinking about other bipedal behaviors across the animal kingdom, such as the giant ground sloths that I mentioned before, kangaroos and raccoons. These are all animals that we see relying on their hind legs for balance while foraging or interacting with their environment. All this got me thinking about behavior I've seen in primates. It's very compelling that all apes, all monkeys, including our closest relatives, are all capable of facultative or part-time bipedalism. We've all seen footage of chimpanzees or gorillas, orangutans walking around on two legs when the situation demands it. whether they're carrying tools, food, or navigating a specific environment, or at play, or struggling for dominance. These are all examples that bipedalism is not unique to humans. The difference, of course, is that we evolved to be obligate or full-time bipeds. We rely exclusively on two legs for movement, and our bodies have shifted to allow for this, to balance us. But it doesn't mean that the adaptation occurred in isolation. So it's easy to see how treating obligate bipedalism as a standalone evolutionary breakthrough overlooks its roots in behaviors common to other animals. The evolutionary trajectory of hominins didn't occur in a vacuum. As outlined previously, bipedal behaviors were already present in various forms across different species. What we see in early hominins, such as Australopithecus afarensis or Homo habilis, is not the birth of bipedalism, but rather the refinement and specialization of a pre-existing behavior. So why then this persistent focus on bipedalism as something unique to us? The answer likely lies in the profound skeletal and muscular adaptations that made us such efficient bipeds. Why do we ask, why did our ancestors first stand up when they were likely already standing? We do have fossil evidence of this. We might ask, why did we become such efficient bipeds? And that is a better question, in my opinion. So we not only freed ourselves for holding tools and carrying children and carrying supplies, but it also set the stage for other major evolutionary changes such as brain expansion. But the hyper focus on obligate bipedalism, I think, risks obscuring the bigger picture. The idea that bipedalism is not an isolated adaptation, but rather one end of a spectrum of locomotor behaviors already present in many animals, including our distant relatives. In understanding human evolution, we need to avoid the trap of exceptionalism. By considering bipedalism as part of a broader adaptive landscape, we can better appreciate the evolutionary processes that shaped our ancestors and the world around them. Rather than seeing obligate bipedalism as a unique trait that separates us from the rest of the animal kingdom, we should recognize it as a specialized adaptation that evolved from a complex interplay of environmental pressures, survival strategies, and pre-existing traits. The shift in perspective is crucial in my opinion. It not only helps us understand our place in the natural world and gives us a place back in the natural world instead of separate from it, but also highlights the importance of comparative research with other species. The behaviors we often celebrate as uniquely human may be special, but they're not always unprecedented. So the next time you watch a chimpanzee or a gorilla, orangutan, or raccoon walk, or a bear walk on their hind legs, remember, bipedalism is not exclusively our domain. We've just taken it further along the evolutionary spectrum. So thanks for coming to my sermon on my feelings about the way we talk about and treat human bipedalism. I appreciate your attention. If you would chuck a projectile point at the like button, I'd appreciate it. It really helps me out. I'm trying to build this channel from scratch, and that will give me more permissions, such as being able to add clickable links and also get into the algorithm a little bit more. As always, my links are in the description. I did not include references as this was an opinion piece. If you want further reading, just ask and I will provide. See you next time.